Yeah, so on the previous slide, I had said I is equal to mr square without really explaining what that meant. So I just want to explain what inertia of movement basically means. So if I have an object, okay, and I want to make it move, so I need a particular force F to make it move, and that is what is known as inertia. Yeah. If I have a bigger object, I'll need a bigger force to move it, so it has more inertia. But what is inertia in terms of making an object rotate? Hmm? So what this means is that I need a certain force F to rotate this object. Okay? This is what is known as inertia of movement. It is basically the equivalent of inertia but in a circular motion. That is what it is in short. So for a bigger wheel, I will need a greater force to make it rotate. Now, what this inertia of movement consists of, what it depends on is, number one, obviously the mass of the object, and second, the placement of the mass. And what I mean by that is that if the wheel were bigger, if it had a bigger diameter, then it would be tougher to rotate. So if I have two discs, okay, one small disc and one bigger disc of the same mass, then this disc will have a greater inertia of movement. Because, I mean, if you see, it's got a greater diameter, right? So it requires more torque for it to move. That is the general explanation of why, if the object is bigger, if the disk is bigger, and there's a greater inertia of movement. Okay, now we've got what the inertia of movement is, right? So now in linear inertia, what basically matters is only the mass. So how do you quantify the mass equivalent of rotatory motion? Okay, so the way we'll do that is by looking at a particular particle in this disk, one particular particle. Okay, now the amount of energy, the kinetic energy that this particle possesses, is half mv square. Now if we were to write this in terms of circular motion, which is essentially what we want to do, convert this mass into terms of circular motion, we will have half m omega square r square. Now we know that omega is the v equivalent of circular motion, right? We know this already. So these two essentially mean the same thing. This is the conversion into circular motion, right? So we can say that in this case, half mv is sort of similar to mr square. So what I'm trying to say is that for this particle right here, the mr square is the circular equivalent of m. Okay, that is the point. That is why we write I, or what is known as inertia of moment, is equal to I is equal to mr square. It is simply the inertial equivalent of circular motion. Now, I was only talking about one point here. There are many points on this object, thousands of them in fact. So the total kinetic energy possessed by them is I is equal to K being the total number of particles, half mi vi square. Now the point is that many objects will have an entirely different answer for this summation, or this integral. It can be written in integral form as well. So essentially I will simply not equal to mr square. It will equal to some other formula. You will get one entire big you know formula for this for different objects, and then you'll equate it, and you'll get different formulas for different objects. You can look further into this. So I'm not going to really derive what the inertia moment of a hollow sphere is. Remember, football can be equated to a hollow sphere. It is roughly a hollow sphere. So you can check it out why later. But the inertia of moment for hollow square is 2 mr square by 3. Okay, now let's move on with this information. Now we shall use this in our previous equation of the previous slide where we equated torque to angular velocity. So we'll put this instead of I, this equation right here. Okay, so now let us get to the crunch. So we have got this equation, Fm is equal to S into V into omega. Now we know, we already derived that omega is equal to torque into the time of the contact between the foot and the ball upon I. And we found out in the previous slide that I is equal to this expression, 2 by 3 mr square, right? So simply plugging in what torque is Fs, or the force created by spinning the football into the radius, or the distance between the force and the center of the football, into the time of contact, the same t, into 3, we got the 3 on the top, upon 2 mr square. Now the second variable is V is equal to Fk by m into t. Now you must understand what Fk is. Fk is basically the force that goes into the translatory motion of the object, of the football. Translatory motion as in that here's my football, okay? There's a certain force that is making it move forward in the forward direction. There's also a force that is making it rotate. The force that is making it rotate, to make it spin, is Fs. But the force that is making it go forward in the translatory motion is what I've defined as Fk. So V is equal to Fk by m, which gives you the acceleration, force by mass, into time t. Now again, you must, like I said earlier, u, or initial velocity, is equal to 0. So you can easily say that V is equal to is equal to F by m into t, like I've done right here. Okay, because your u is equal to 0. I shown this before in an earlier slide. Okay, so let's get down to the math. So I can write this is equal to Fr. I'm simply plugging in the values, okay, into Fk into t square 3 into S divided by 2 mr. Okay, so there has to be an r on the top. I think I missed that. Into r, and this is r squared. So we strike this off, and now the entire point. So now we've got Fm is equal to this expression right here. Okay, now our entire point is to prove that Fm should be greater to the weight, or Fg, of the ball. Now the weight of the ball, an average ball, is basically 4.5 newtons. 4.5 newtons, which means that its mass is around 450 grams. So, and the average point of contact between a footballer's foot and the ball is 0.05 seconds. And the mass I said earlier is equal to 0.45 kgs. Point right Okay. Now, another thing that you must understand about FK and FS is that the total amount of force that the footballer puts on the ball is basically equal to Fk plus Fs. Makes sense, right? Because there are two kinds of accelerations or motions that we get. We get translatory motion and we get a rotatory motion. The total amount of force is can be divided into these two parts. Now, my point is to prove that it's humanly possible for the ball to have a backspin and that it defies gravity. So the maximum, so now over here we know that Ft has to be divided into these two, and they have to be added to equal up to Ft again. Now the thing is that both these values are being multiplied. So we need to find how to split a number and to multiply the two numbers that we get and get the maximum amount. And that is possible if we split a number, say we've got a number 10, okay? And we need to find two numbers that add up to 10. And xy should be the maximum. Should be a maximum value. Then you can take many examples, but basically when we get the maximum value is only when we have got x is equal to y is equal to 10 by 2. Now, if it's x is equal to y is equal to 10 by 2, it will be 5 into 5 is equal to 25. What if we take some other combination? Let's say 6 plus 4. 6 into 4 will be equal to 24. That's lesser than 25. Let's take another combination. 7 into 3. 7 into 3 is equal to 21. Again, less than 25. Let's take a separate number from 10. Okay? Let's take 20. So 20 divided by 2 is equal to 10. And 10, so x is equal to y will equal to 20 by 2. Not 10 by 2, 20 by 2, which is equal to 10. And 10 into 9 is 100. Okay? Now let's take another combination that adds up to 20. Let's take 11 into 9. 11 into 9 is 99, which is less than 100. So we can safely say that in order to get Fs into Fk to be the maximum value, okay, we'll have to put Fs is equal to Fk is equal to Ft by 2. So we'll have to put, so the maximum value for Fs into Fk will be Ft by 2 into Ft by 2, which is then equal to Ft square by 4. Okay? Okay. Now we can say that Fm is equal to 270 square by 4. 270 square is the same as Ft square by 4. I just plugged in Ft square by 4. Now Ft is the total amount of, is the average, force put by a footballer, which is 270 newtons. Okay, this is the average force a footballer puts on the ball, 270 newtons. So Ft square by 4 it will be, so 270 square by 4, which is equal to the maximum value of this basically this part of the expression. Okay, this is equal to into 0.05 square into 3 upon 2 0.45 yeah, into s. Okay, now just wait for 2 minutes. I'll just put this entire thing into my calculator. If you just wait for a minute. Okay, so just a minute. 0.56 into 270 15 point. So this comes around 151.2 into s. Now s is always greater than 1 for any football. It will always be greater than 1. You can check this online. Okay, but the important point here is that my Fm is much larger than my Fg. For Fm, I've got 151.2 into some number greater than 1, maybe 1.1 or 1.01 or 1.023 or something like that, versus a mere 4.5 Newton. That's it. So I can easily say that Fm can equal or be greater to Fg. In fact, it'll always be greater. So that means that if a footballer has a lot of skill, such that if he applies his total force and he's able to divide Fk and Fs in such a way that their multiplication is around the maximum value that it can get to, that he kicks the ball in such a way that it gets a good translatory force and a good spinning force, such that this product will be so big, it'll in fact be much greater than Fg. So after all, my friend seems to be completely, well, where is it? Where's the word? Wrong. Absolutely wrong. He was simply wrong. So what we're trying to say is that the ball can go and above and defy gravity. There's no simple answer, oh, gravity will just pull the ball down. No. But yes, this gets us to another question. If it is possible for the Magnus effect to overcome gravity, then which projectile path will the ball take? Will the ball initially go up, and when it's coming down suddenly go up again? Or will it just stay in that trajectory? Will it just stay prolonged in that trajectory, and then after some weird amount of time just come back down? That is one question which, well, is a further question. I do not know how to answer that. If you guys have got any ideas, please feel free to, well, share them with me. I'd love to know about this. Also, at the end of the day, I guess he's wrong, and I guess footballers are already must be using the backspin. But anyway, the point of this video was not exactly to prove the problem or to solve the problem that I set forth. It was in fact to learn many things along the way. We learned Bernoulli's principle, we learned Magnus effect, we learned the torque and, well, what is it, circular velocity thingy. We also saw a bit into inertia of movements, and that's what I call a good day, you know, when you get to learn so many things. That was the point of this video. Actually, the problem was just an excuse to look at all these four things and, you know, to see a kind of link between all these things. The problem was simply an excuse. And if you see further in this channel and you see further problems, always remember that these problems are simply an excuse to do what we love. Okay, that's not a very good smiley. Never mind. Well, people, I hope you had a good time. And yeah, that's about it. See you next time.